Hello everyone, welcome to the video. Today we're going to be looking at 7.8, the last section in chapter 7, where we're going to be factoring polynomials completely. So we want to know how can you factor a polynomial completely. A lot of different situations, a lot of different rules come into play when it comes to factoring out completely. One, you have to be able to see if you can factor out like a monomial factor, like just like one term, can you take it to the outside and factor from there? Then you have to realize, is it a binomial? Is it a trinomial? Or today we're going to be looking at four-term polynomials. How do we factor that? Well, we're going to be factoring four-term polynomials by factoring by grouping, all right? So what we're going to do is essentially you're going to factor the greatest common factor out of each pair of terms. Once you look at these two terms, you're going to factor out what is called a common binomial. And I'm going to show you what that kind of looks like throughout the different examples. So there are some rules that we have to follow when you are factoring polynomials by grouping. So if you look at, let's say this first example here, I got x cubed plus 3x squared plus 2x plus 6. All right, in order to solve anything by grouping, they must be in standard form. Largest degree in the front and in decreasing value from there, or then you have your constant value at the end if we have one. Okay, so from there, what we're going to do is looking at this. I always say whether it's in standard form or not, especially when it comes to grouping, rewrite it. So x cubed plus 3x squared plus 2x plus 6. The grouping now comes into the first two set of terms. So I'm going to put parentheses around them. I'm grouping them. And I'm going to put parentheses around the last two terms, leaving the sign that's in between the two parentheses on the outside. So in this case, it's a plus. All right. Now what we're going to do is you're going to look at each individual parenthesis. You are going to factor each individual parenthesis. So now, what can you factor out of x cubed plus 3x squared? And in this case, it's going to be an x squared. What's left over is x plus 3. I have the plus here, so I'm going to write the plus into there. Looking at 2x plus 6, I can factor out a 2. And what's left over is x plus 3. Now, what you should have is whatever's inside these two parentheses, they should be the exact same. If not, we did something incorrect. What this is now we have a common binomial. Now what we're going to do is this. Whatever that common binomial is, you're going to write it in. So we got x plus 3. The rest of the parentheses is what's left over, x squared plus 2. The last thing you have to kind of do is just take a look at each set of parentheses, see if you can factor out even further. In this case, you can't. So that is my factored out completely polynomial. Looking at example B, this particular one, you're going to have to rewrite it. Okay, so reason for that is because x squared is my largest degree, the next largest term is going to be x, not y. So it's going to be x squared plus x plus xy plus y. So now I can group this and I can group this. Factoring out x squared plus x, it will be x on the outside, and then I'm left with x plus 1. Put a plus right there because it's what is in between them. Between the two values, I can factor out a y, and I'm left with x plus 1. Did I have the same thing? Absolutely I do. So that's our common binomial. So now my factored out completely polynomial is x plus 1, because they're the same, and what's left over, which is x plus y. All right, here, looking at it again. First off, is it in standard form? 3, 2, 1 constant. We're good there, so I'm just going to rewrite it. A cubed plus 3a squared plus a plus 3. Group them up. Here I can factor out an a, so actually a squared, and then this turns into a plus 3. Now put the plus here. Now between a plus 3, you can't factor anything because there's nothing in common. So what I'm going to do is I'm just going to leave on the outside as 1, and I'm just going to write it as a plus 3. Are these the same? Yes, that means we have our common binomial. So now I am writing it as a plus 3 times by the quantity of a squared plus 1. This is almost a sum and difference pattern, but it's not because it's plus, not minus. So that is all that's left. Looking at example 2 here. Now that the y squared is our lead coefficient, that means that we have to rewrite it as y squared plus 2y plus yx plus 2x. So group them up. Now here, this is going to be what, y, and then it's going to be y plus 2. Got the plus, write that in there. And looks like we're going to have this as x, and then this is going to be y plus 2. We have our common binomial, so I got y plus 2 times by the quantity of y plus x. So now, in these types of situations, they want us to factor it out completely. So what you need to do first, whether it's 2 terms, 3 terms, 4 terms, whatever it is, initially look at and see is there one term that you can take out right off the bat and factor it. Just factor out one term. So, I have a 3, a 6, and the negative 18. All of them are divisible by 3. So I'm going to put a 3 and put it to the outside. But also, they all share a common variable of x. So I'm also going to write in x to the first power because that's the smallest degree of the 3. So now I'm going to write in what's left over. So now this is going to be x squared plus 2x minus 6. So now I have a simple trinomial inside the parentheses, so I can factor it from there. So I'll drop down the 3x. This turns to parentheses, parentheses. I got x here, different signs. So one's plus, one's minus, larger numbers attached to the plus. Two values that give me a product of 6, but their difference is 2 is what we got? All right, so I'm trying to look for two values that give me a product of 6, but their difference is 2. So you got 6 times 1, 2 times 3. So the difference of 6 and 1 is 5. The difference of 3 and 2 is 1. So essentially, you can't factor this out any further. So all you have is 3 times it by the quantity of x squared plus 2x minus 6. Looking at the second example, 7, 28, I can factor out both of them. Both of them are divisible by 7, so I can put the 7 on the outside. They both have a common variable of x, and so x squared. So what's left over is going to be x squared minus, what, 4? Now, looking at this, you know, 7x squared, can't do anything else with that. But this, x squared minus 4 is a sum and difference pattern. Perfect square, x squared, perfect square, 4, subtraction in between it. So now this turns into x plus 2, x minus 2. And you got to make sure you do that extra step because then you're not factoring out completely if you don't do that step. Here we have an equation. So anytime you have an equation, remember you got to set it equal to 0. So subtracting 10x from both sides, I got 2x to the third plus 8x squared minus 10x equals 0. Now, what I'm going to do is see if I can factor out one term. In this case, we can, because 2, 8, and negative 10 are all divisible by 2, so I'm going to put 2 to the outside, and they all have a common variable of x, so I'm going to put x to the outside as well. So I'm left with x squared plus 4x minus 5, and set that equal to 0. So got my 2x. Let's see if I can factor this one out, unlike the other one. So this is x and x, different signs, larger numbers attached to the plus, two values give me a product of 5. Difference is 4, which would be, what, 5 and 1, because 5 times 1 is 5, and 5 minus 1 is 4. All right, we found it. So because it's an equation, we must implement the zero product property. So 2x will be equal to 0, x plus 5 will be set equal to 0, and x minus 1 will be set equal to 0. That means x could equal 0, x could equal a negative 5, and x could equal a positive 1. All right, so like I said, give these a try. I'm not going to go over all of them, but I um, encourage you to look at these problems. If you are struggling with something I didn't go over, please comment down below. I'm more than happy to work them out. Let's look at number 5. It's just asking to factor out completely. It's not an equation, so we're just factoring it out. There is no number that I can place on the outside, but they do share the variable m. So I could put m to the outside, which then leaves me with m squared minus 2m minus 8. So then I have m times it by the quantity that's here. I can put m and m plus minus. Is there a value where they give you a product of a, but the difference is 2? And in this case, it would be what? 4 and 2. Okay. If we looked at, say, like number 7, 30 equal to 0, so we're good there. I can factor out an x. So now I'm left with x squared minus 25 is set equal to 0. Well, x is, is what it is. Can't factor anything else. But this is a sum and difference pattern. So this is going to be x plus 5 times it by the quantity of x minus 5. Set that equal to 0. So that means that x could be 0, x plus 5 is set equal to 0, and x minus 5 is set equal to 0. So x is 0 is already there. X could equal -5, and x could equal +5. You could also put plus or minus 5 if you wanted to as well. All right, last problem. It states here that a terrarium is in the shape of a rectangular prism, has a volume of 4,608 cubic inches. Its length is more than 10 inches. The dimensions of the terrarium in terms of the width are shown. Find the length, width, and height of the terrarium. So they're telling you that it's what, 36 minus W, W, and W plus 4, all in inches. So they give you cubic inches, which is volume. Anytime you're dealing with volume of a rectangular prism, it's going to be length times width times height. So we're going to substitute it in. So the length is 36 minus W. The width is W, and the height is W plus 4. The volume they gave us, the 4,608. So in this situation, let's multiply out our length, width, and height before we set the equation equal to 0, because eventually that's what they're asking us to do. So I got, and if I go here, I get 36 minus W. I'm just going to distribute the W, so now I have W squared plus 4W. So now I got 4608. This is going to equal to, so I got 36 W squared. I have 36 times 4, which is 144W. I have minus W cubed, and I have minus 4W squared. So with that, I am going to, actually what I'm going to do is this, as I'm going to put everything all on the left-hand side because my lead coefficient right now is negative, so why not? So I'm going to put everything over to the left-hand side, which means I'm going to add W cubed to both sides, which gives me positive W cubed. And I'm going to 30, so what, 36 minus 4, that gives me 32, because I combine the like terms, so it's positive 32, so I'm going to minus 32 W squared on the left-hand side. I'm going to have minus 144W, because I took care of this, took care of this, took care of that, I took care of that. And then I have plus 4608 and set that equal to 0. All right. We'll see if I get the right values. Because it's 4 terms, we got to group it. And it's in standard form, but regardless, I like to rewrite it. I'll just leave the 0 and I'll solve it after I factor it. So group it up. So this turns into W squared. So now I have W minus 32. Minus goes right here. Now, because I have the 144, I'm assuming if I took 4608 and divided it by 144, I get 32. Awesome. So 144 goes there. Now, because I have this negative, it's going to be W minus 32. Think about this. Negative 144 times by negative 32 is positive 4608. So that's why I always rewrite it just to make sure that the signs are correct. And it usually is a little bit trickier when there's a negative right there. So keep that in mind. We have the same thing there. We have a common binomial. So now I'm going to say that this is going to be W minus 32 times it by W squared minus 144. And that's going to be set equal to 0. All right. So W minus 32 I can't do anything with. That's fine. This, on the other hand, is a sum indifference pattern. So I can say that this is going to be W plus 12, because square root of 144 is 12, and this is W minus 12, set equal to 0. Here I can say that W is going to equal 32, W is going to equal negative 12, and W is going to equal a positive 12. So let's look at this. So right off the bat, we can disregard the negative 12 because it's negative. We can't have a negative distance. So if we look at positive 12, well, let's see if that works out. So if I put 36 minus 12 from here, that gives me 24. And then I have 12, and I have 12 plus 4, which is what, 16? Does that all work? 24 times 12 times 16, 4608. So we can say that 12 inches works. So circle that. Let's try 32. So if I went 36 minus 32, I get 4. And 32. And I get what? 32 plus 4 is 36. 36 times 32 times 4. That's also 4608, but you know that the length is 10 more inches. Well, if you look at this here, it says the length is 10 more inches. So that wouldn't work out. So the only one that makes sense doing the parameters would be the 12. So W would have to equal 12. and that is being able to factor polynomials completely. Hope this helps. Till next time.